Okay, class, let's go over our test review. The first set of questions asks you to write using a positive exponent. So each problem has a negative exponent. If you remember the negative exponent, it flips things around. If it's on the bottom, it's going to flip it to the top. If it's on the top, it's going to flip it to the bottom. Okay, so on number 1, here we have 1 over 3 to the negative 9. So it's negative in the denominator, so that means it's going to be positive in the numerator, so just 3 to the 9th. Number 2, we have 4 to the negative 7th. So that is in the numerator, so that means the negative exponent is going to flip it to the bottom. So this will be 1 over 4 to the 7th power. Now, if the base number is negative, it stays negative no matter what. Okay, so in this one right here, okay, we're going to, the negative 5 will flip it to the bottom because that is on top. So we end up with 1 over negative 8 to the 5th power. And that's how we write those with the positive exponent. Okay, the next section says write using a positive 1 exponent expression. So we've got to remember what we have to do to put these together. So if in number 4, if our bases are alike, we add our exponents. So this ends up being c to the 4th power. Now, number 5, our bases are different and our exponents are the same. So that means we multiply our bases and we keep our exponent. So this will be 20 to the 3rd power. Okay, on number 6, this one we've got 6 to the 4th times 6 to the 3rd. So just like in number 4, we're going to keep our base and add our exponents. So this is 6 to the 7th power. Now, number 7, this one's kind of a tricky one, because you'll notice you've got 5 to the 6th power, but you also have divided by 5 to the negative 2nd. Okay, well, in a division problem, you can do it one of 2 ways. One, you could do what the negative does and it flips it up, and we end up with 5 to the 6th times 5 to the 2nd. Or in a division problem, we just subtract our exponents. So if we have 5 to the 6th minus negative 2, that really becomes plus 2. Okay, so we end up with 5 to the 8th power. Okay. On number 8, okay, this one's going to be 7 to the 1st power, because anything to the 1st is going to be itself. Now, if I have an exponent raised to an exponent like we do in number 9, we're going to multiply our exponents. So we end up with 6 to the negative 16th. But in the instructions, it says write as a positive exponent. So this one's going to flip over and be 1 over 6 to the 16th power. And then number 5 would be 1 over 5 to the 3rd power. So that's how we write using a positive 1 exponent expression. The next section says to evaluate, and it says don't give me any decimal answers. So this is that section that if you actually type it in and you get a regular number, you just write it down. Okay, if you type it in, you get a decimal answer, then you're going to have to do something to it. So on number 11 here, if you were to type this one in, okay, this 4 to the negative 4 is actually going to go to the bottom because of the negative, and the 4 to the negative 6 is going to go to the top. So this really ends up being 4 to the 6th power divided by 4 to the 4th power. Okay, well, if our if our bases are alike and we're dividing, we subtract our exponents. So you end up with 4 to the 2nd, which is really just 16. Okay, 9 to the 3rd power. Okay, so this is 1 over 9 to the negative 3rd. So the negative exponent is going to flip it to the top, and it ends up being 9 to the 3rd power. So we go to our calculator and type in 9 to the 3rd power and get 729. Okay, number 13, we've got 7 to the 5th. So we just type that in. So 7 to the 5th power, and I end up with 16,807. Okay, number 14, we could simplify this one first, or you could just type it in. This one actually ends up being 24 to the 2nd because we multiply our bases and we keep our exponent. So we go to our calculator, type in 24 to the 2nd power, and we end up with 576. Now, number 15, we've got 9 to the 0th power. We know anything to the 0th is always 1. Okay, moving on. Now we've got the next section, simplifying radicals. And we know to simplify radicals, we've got a 3-step process. Step number 1, break your number inside the radical down using prime factorization. So we'll do that part first. So I've got 180 and we'll simplify that to 18 times 10, which then simplifies to 9 times 2 times 2 times 5. The 9 breaks down into 3 and 3, and everything else just slides. So I end up with really the square root of 3 times 3 times 2 times 2 times 5. Okay, so on a square root, I'm looking for two of a kinds. Okay, so I've got a pair of 3s and a pair of 2s that'll jump out. So that will end up giving me 3 times 2 times the square root of 5. Now, everything that's on the outside here, I put it together with multiplication. And anything that was left on the inside, I'd put it together with multiplication. So we end up with 6 times the square root of 5 for our answer. Okay, next, we go do 196. Now, I'll be real honest, I don't know what'll give me 196. Well, I do, but let's say we didn't know what 196 was. So we got 196, and we got to break that down. Well, I know I could divide it by 2. So I type in 196 divided by 2, and I get 98. So 98 times 2. Well, 98 again, I could divide it by 2. So I divide it by 2. And I end up with 49 times 2, which is a number I recognize. And now 49 breaks into 7 times 7. And then the 2's slide right on down. So the square root of 196 gives you 7 times 7 times 2 times 2. So now we're still looking for two of a kinds. So the 7's will jump out. The 2's will jump out. And I'm left with just plain old 14. Because if everything jumps out, I don't need to leave a radical there. Now we have this big one. 13,500 to the cube root. Okay, well, I know we've got 2 zeros on the end of that, so that means I can break 13,500 down into 135 times 100. So the 100 will break into 10 times 10, which is then 5 times 2 times 5 times 2. Okay, so now we got to do the 135. Now the 135, I know it ends with a 5, so that means I can divide it by 5. So 135 divided by 5 gives me 27. So that will be 27 times 5, and now I know 27 is 3 times 3 times 3. So 13,500 will break into 3 times 3 times 3 times 5 times 2 times 5 times 2. Okay, so we're looking for pairs. I've got a pair of 3s, I've got a pair of 5s, and I have a pair of 2s that can jump out. Okay, so that means I'm going to have 3 times 2 times 5 times the square root of 3. So we take the 3 and the 2, multiply that together, get 6, times 5 gives us 30, times the square root of, or times the cube root of 3. Oh, and I just forgot about something. I just did a square root on that one, and I need to do a cube root on that one. So let's go back and look at that one again real quick. Hold on. So let me rewrite those numbers in there because I just messed up. Oh my goodness. Okay, so again, we've got a cube root of 3 times 3 times 3 times 2 times 5 times 2 times 5. Okay, again, I'm glad I caught that because that would have been a big mess up. So now, because it's a cube root, I'm looking for 3 of a kinds. So that means a 3 will jump out. Nothing else. Okay, so 3 times the cube root of, can we put this back together? 10 and 10 make 100. So we should end up with 3 times the cube root of 100. Because that cube root, that little bitty 3 there in the corner says I'm looking for 3 of a kinds, not 2 of a kinds. Ooh, I'm glad I caught that. Okay.